Greetings, my fellow software test engineers, and welcome to the Software Test Automation Revealed YouTube channel, or STAR for short, hosted by me, Cody Gibson. Also, happy Valentine's Day on this very fine February 14th. This is episode 4, Automatic Logging of Test Results and Test Execution. I'm hoping this is a very interesting episode for you because I'm going to demonstrate using a couple of external third-party tools, which are free to use, just how you can achieve automatic test logging without having to have a bunch of explicit log statements sprinkled throughout your code. While we're at it, don't forget to hit that like and subscribe button so that you can be notified as I upload new content to my YouTube channel. And because it is Valentine's Day, don't be surprised if we see Cupid hanging around here from time to time. So now let's get into it. Like I said, we're going to be using a couple of external tools. We're going to be using Apache Log4Net as well as PostSharp Community Edition. Apache Log4Net is a free and I believe open source utility, a library that can be used for all kinds of advanced logging. PostSharp is available in 2 editions. There's the commercial production edition, which you have to purchase a license for, and there's the free community edition. Fortunately for us, just for logging, the free community edition serves our needs perfectly. Here's an example of the log output when everything is all done and put together. We start off with the date and time when a log was done. What was the logging level? Now, Log4Net has the concept of multiple logging levels. You can learn about those in their documentation. In this episode, I'm not going to take the time to teach you Log4Net. We start off with log file stored at, and you notice it's kind of long, but every test will get its own unique log file, separate and independent from all the other tests. Then we're logging which browser the test ran in, what version the browser was. We log the fact that, hey, we completed starting up the Selenium WebDriver, and we're logging what was the URL at the start of the test. Now, these symbols indicate that the test called this first method. So it's calling the method or the test step NavigateToHome, passed it no arguments. And then these symbols indicate that the method exited. NavigateToHome returned back to the main test, and it returned a home page object. Then the main test called HomeActionOne, it called it with this parameter. And then inside this method, we do have an explicit log statement. And when we look at the actual code, I'll show you those log statements. So it logged doing HomeActionOne. Now notice we've got an indent level here, and that's because HomeActionOne actually makes a call to internal method 1, no arguments. Method 1 in turn calls internal method 2, again with no arguments. And then finally, method 2 exits. So method 2 now returns to method 1. We see method 1 returns with no results for both of these. It returns back to HomeActionOne. HomeActionOne finally exits and returns back to the main tests and returns a home page for the main test to use. Now the main test calls HomeAction2 with this parameter. HomeAction2 also has an explicit log statement. Doing HomeAction2 is what it logs, and so on. There are many more steps to this particular test. I'm not including them all. Near the bottom of the test, we see at the end of it, the main test calls NavigateToFeedback with no arguments. NavigateToFeedback exits, and it returns a feedback page. Then the main test calls FeedbackAction1 with this parameter. We also have an explicit log statement inside FeedbackAction1, which then returns back to the main test. Now the main test calls FeedbackAction2 with this parameter. We have another explicit log statement inside FeedbackAction2, which then returns to the main test. Now the main test is finished. So the base class now takes over the cleanup step, and we're logging what was the result of the test. This is the end unit test result. We are also logging how long the test took to execute. In this case, 23.2 seconds. So here's what a test looks like that failed. Notice we have an error log. With the exception, no such element. So the test tried to find an element, it could not find that element, and therefore Selenium itself threw this no such element exception. We notice we have a complete stack trace as well as a line of code that failed. So we can go and look at HomePage line 64 to try to diagnose what happened. Why did it not find the element that we were expecting it to? And then, just like the others, we're logging the test result. In this case, end unit says the test failed with a fatal error. And the test duration, 7.2 seconds. For our test logs, all of the logs are going to be going into this test results folder. Now, where is this folder? Well, let's start with the root of our test solution. We have our main root folder for Star.Test.Solution, and inside there are Star.Tests. So that's our main project containing all of our tests. Then you go down into bin, then you go down into debug, then you go down into .NET Core App 3.1. Now this is where all of the compiles get put. So the DLL containing the tests is put into this folder. So what we do is we create an additional folder called test results. And if you notice, every time you run a test suite, you're going to get a new folder with a date and time stamp. Inside each of these is going to be a set of log files for the tests that executed. So make sure you monitor the contents of this test results folder from time to time, because these folders are technically, they can grow infinitely. So periodically you want to go in here and clean up the test results folder so that you don't run out of disk space because you've got a million log folders in here. Now, like I said, each folder that gets created gets a log file, one log file per test that ran for that test suite. In this case, we ran 6 tests as part of the test suite, therefore we have 6 log files. Each log file is named for the test along with its parameter called for the test. So that's how it's starting to look. So these are your results that you can take advantage of. As noted earlier, Log4Net is by Apache. It's free. You can get it from their website right here, Apache. Now you don't really need to download and install anything. It's available as a NuGet, which I've already installed the NuGet as part of our Star.Test solution. The NuGet gets installed into Star.Core and Star.Pages, so that both of these projects can take advantage of Log4Net. Optionally, you could add it to Star.Tests if you want to do explicit logging from the high-level tests. I choose not to. I prefer to do all of my logging from my test steps. I prefer nothing but very, very high-level tests here and no logging at this level. It makes no sense to add Log4Net into the models because there is no code. These are nothing but data models, plain old C objects. There's no code in here to log. Log4Net does need to be configured. Now you can configure it programmatically, or you can configure it using a config file. I've chosen to configure it using a config file because I think that's easier, it's more flexible, and less code to write. Here's the contents of that config file. The one thing that is mandatory is this root. Root must be applied. Everything else in here technically is optional for Log4Net. I've defined 2 loggers, one for PostSharp, which would be logging all of our test steps kind of automatically and magically for us, and another logger for our explicit log statement. So this one is only going to be used by our explicit log calls. Now, if you notice, these reference appenders. This is the name of an appender, which is ref file, ref console. These match these names here, this file and this console. These are appenders. These instruct Log4Net where to put and how to format the individual log statements. So we're formatting it with a date and the level, the message, the log message, as well as a new line. Same thing for logging to a file. So the format is the same for both of them. Optionally, you can treat them differently if you want. That's completely up to you. The other thing to make note of is that Log4Net has the concept of levels. You can actually set a logging level. They have debug, as well as info, as well as warning, as well as error, as well as fatal. I'm not going to go over what each level does and how the levels work. You can learn about those by referencing the Log4Net documentation from their website. This is the code used to create the loggers and configure Log4Net. So we set up a few variables first to be used during the configuration. And then we say thread context. This is a Log4Net explicit object, .properties, and we set log path. So we are setting the log path, log file path for every test. Because this is a thread context, Log4Net is very much thread safe and thread aware. So it keeps track of a log for each and every test individually, making it very, very thread safe. And then we go ahead and we configure our logger. We identify which logger we're going to configure, which was named right here. And then we also point it to which config file to read from. So we're pointing to this config file for Log4Net to read and get its configuration from and configure itself using that config file. Then I go ahead and I create myself a couple of loggers for our test code to use. I create one explicitly for PostSharp to use. Only PostSharp is supposed to use this particular logger. And then this is our general logger in which we can use for any of our optional explicit logging. The very next thing we're going to do is go ahead and use it. We're actually going to log where the log file itself was stored at. So we're actually capturing and storing the log file path. So if you remember back in the beginning when I showed you the example of the log file, this is where this is how we're logging that statement into our log. So the other tool we are talking about is PostSharp. PostSharp is not free open source, but fortunately they do have a community edition which serves our needs perfectly. Now you must go onto their website, which you can see right here. You must go to their website, go download, and then download PostSharp tools for Visual Studio. You must install this. That is mandatory for PostSharp to work. PostSharp also has a NuGet, and I've installed the NuGet into the project. Okay. During the install process, you're going to be asked for which license to license it with. Please select the PostSharp Community license. Now they warn you it has a limit on the number of lines of code, but there is a way around that, and I'll show you how we get around that. Like I said, PostSharp has its NuGet. We've installed this NuGet into the Pages package, our Pages project. We don't want it installed anywhere else because we don't want method logging in the core. We don't want method logging in the tests. We only want method logging in the pages themselves. PostSharp Community Edition, yes, it has a lot of free features. They say it's limited to 1,000 lines of code, but they actually have two modes of execution. Production mode is the default mode. That's when you would have the 1,000 lines of code limitation. But you can also set it to developer mode, and developer mode does not have that limitation. Instead, it has a limitation that the logging messages will not work 24 hours after compilation, which actually serves our needs very, very well, because we're not normally compiling it and then running the same tests from that compiled code 24 hours later. Normally, like in a CI/CD environment, the CI/CD system is going to check out the code, compile it, run it, and run the tests right out of it, right after it. So we'll be running tests within a few minutes of compilation, not 24 hours. In order to get into developer mode, you must add this PostSharp.config file, and it must have this content. Now, I've already done this in our test project, so you don't need to worry about it. But I'm just informing you so you are aware. All right. You can see in our project, I've added this PostSharp config file, just as documented. And here's where the real kind of like black magic is. We have a new log method aspect. What this does is it actually intercepts every call and every return and every exception that is thrown in the pages class. I'll show you the details how that works when we get to the actual code. And let's go take a look at that code right now. All right. The log method aspect is this one right here. So what we are doing is we are configuring to say, hey, PostSharp, I want you to capture and intercept every method that matches this pattern, this name pattern, Star.Pages.cs. So any method, anything in the namespace underneath pages is going to be intercepted by PostSharp. The thing is, it must be a public method. We're not going to intercept and log private methods, internal methods, and so on. We're also telling it, do not log or do not intercept the dispose methods, the constructors, the getters and setters of properties, the is active method, which I've talked about in a previous episode. So what PostSharp actually does then is on entry, this is an interception. Every time a method gets called it's activated in the pages class, this method is going to run first. So just before the method executes, this code executes. And this code is logging the fact that, hey, we entered that method. We're generating our log message here, and then we're updating our PostSharp indent. Now I noticed, remember, we have an indent value. So that indent value is being calculated and added here. You can adjust it as you want. I've set it to a value of 2. So every method that gets called, the indent level goes up by 2. Every time a method returns, the indent level goes down by 2. And then every time a method successfully exits, this method gets called automatically by PostSharp. You don't have to think about it. So we generate our message for our log, and we log it right here. And then if an exception happens in one of our methods, this method gets called. We're going to we're going to log that exception right here as part of our logger, all automatically. All of this stuff happens kind of like black magic. You, the tester, don't have to think about it. PostSharp does all of this automatically for you in the background. Now, these methods aren't truly a part of PostSharp. They're just utility methods that are called by these main methods. Okay. The other important thing is this base web test. That's where we had to do a lot more changes. I've had to add a lot more properties. Now, this is a thread-safe property structure. Every test that's executing gets its own thread-safe properties structure. So every test has its own PostSharp index, its own PostSharp logger, its own general purpose logger, as well as its driver. That didn't change. We're added a test results folder. That's where we have test results / date and time / log file. And then we've created a property for the test starting time, properties for the logger, the test WebDriver, lots of properties which are thread safe properties for each and every test. Now we've modified the one-time setup. One-time setup, we are calculating the test results folder. Test results folder comes from the NUnit work directory. Now the NUnit work directory would be where the DLL, the test DLL lives. So we're grabbing that directory, and then we're going to append test results to it. We're going to append a formatted date and time now string to it, and that's where we're going to store all of our test log files. Now, as I already went over a little bit earlier, we're creating a few variables for our logger, and we're setting our log file path for this particular test. We're configuring it. We're creating a PostSharp logger, a general logger, and using it. I've also added a number of useful log statements. We've got here running tests on which browser and the browser version. So we're using the name of the browser and the version of browsers being added to the log. We're logging the fact that, hey, the WebDriver initialization finished. We're logging what is the URL at the start of the test. If an exception occurs during initialization, we're going to catch that and add that into our log. So we can actually see in our log, hopefully the reason for failure to initialize the WebDriver. In test cleanup, we've added a couple more log statements. We've added, what is the test result? So we're logging the NUnit outcome right here. We're logging what was the test duration right there. If an exception occurs, we're going to add that exception into the logger. So instead of using the NUnit console output, we're going to use our new logger. Same thing here. If the test failed, we're going to add we're going to log what was that error. And well, we're going to log what was the URL at the point of the failure. Now, what else have we changed? So the only thing we've really changed here is instead of using the NUnit console output, we are using our new logger once again. Another thing that changed was the base navigation. We are now passing logger into this generic wait for elements, which is part of these extensions. So this is the WebDriver extensions. So we can see in our WebDriver extensions now, all these methods take a logger object. So instead of using the NUnit console output, we're going to be using the logger itself directly. And that's the only real modification to all of these extension methods. We've added a logger here, so it can be used, a logger here to be used, and so on and so on. Okay, WebDriver init change. Oh, the only thing that changed was I removed a using statement that was not needed, so not going to worry about that. IWebTest had to be changed. We've added these properties, which can be used by the tests and the test steps. And so I had to add them here so they were available to our test and test steps. Now, the pages themselves really didn't change much. Instead of using the NUnit console, we're using the test logger. Now, for demonstration purposes, I've added internal calls. So we're calling internal method 1, which is right down here. Internal method 1, which calls internal method 2. Now, they don't do anything. I added them just for demonstration, just so you could see what they look like in the log file, including their indentation levels. Other than that, these pages did not change. The rest of them, all we did was change from the NUnit console output to the logger. We have the PostSharp.config file, which we were added. We've got the log4net config file, which we've gone over and added. ProDinnerTest. Yes, I added this test so you could see what does the log look like when a test fails. Now, this, let's look at this. So this step will always throw an exception because I've told it, try to find an element using an ID that I know does not exist on the web page. So I know this method will always throw an element not found exception. And I've done that for demonstration purposes so you can see what the log file looks like. I've added this just so we're not waiting 2 minutes for the implicit wait to time out. We're only going to wait 1 second, and then we'll see the exception being thrown by the WebDriver. All right, that is pretty much it. That's all the changes. Let's watch these tests run in action. Now it's compiling the program. In a moment, there we go, launching the browser. And you might notice it has launched 6 different browsers and it's running all 6 tests in parallel. We'll just watch and let it finish. It's almost done. There, it is finished. And we have 5 tests passed, 1 test failed, as we expected. So let's go ahead. We can look at this failure. We can open this additional output, and we can see all this additional output. So just like I showed you in previously the log, we can see the details of this test being executed and the exception being thrown and the exact line of code that threw that exception. We can go back and let's look at a past test like this one right here. Again, we can open additional output, and there is all of our output. We've got the indent level as I described. Everything is here. We can see it took 30.3 seconds to execute. And we can go ahead and have a look at the result folder. Let me find that for you here in File Explorer. Just a moment. I've got it off screen right now. I'm drilling down into where the results are going to be. And almost there. Okay, so we've got drilling down. Okay. So we can see here, here's our test results folder. We have a new folder that was for the one executed today. If we open this, we can see all of the log files. If I double click on one of these, we can see the contents of that log file. So this is the one that failed versus, let's open up another one that actually passed. So here's one that passed. And there's all the details of it. So you can see we've got logging. We're saving them into these log files, as well as putting it out into the console. That should be very, very useful to you. I appreciate you tuning in. Look forward to seeing you in episode 5, where we talk about fetching test input data from a database. We're going to be using MongoDB as our database. You could use almost anything. I happen to really love MongoDB. It's my personal favorite. We're going to be fetching the test input data and using it in a very strongly typecast manner so that it's easy for your tests to consume and use. Now, please don't forget to click that like and subscribe button so you get notified when I upload episode 5. And I'm shooting to upload that in about a week. Thank you all very much.